Determine the equation of the tangent line to y equals square root of 3x plus 12 at x equals 8 using the slope of the tangent line equals the limit as h tends to 0 of f of a plus h minus f of a over h. So in this form here, a represents the x-coordinate of the tangent line, and h represents the displacement from the tangent line, from the x-coordinate of the tangent line, as we're moving the secant closer and closer to the tangent line. So as h goes to 0, that secant becomes the tangent line when h reaches 0. So what we're going to do here is we're going to define f of x first. F of x is the function that we're given here. So square root of 3x plus 12. We have a equal to 8. And so now we can plug it into the expression that we're given. So the limit, the slope of the tangent line equals the limit as h tends to 0 of f of a plus h. So a is 8 and h is the displacement. It's the one that's going to 0, right? Minus f of a, so f of 8 divided by h. We can now expand this. So f of 8 plus h is going to be the square root of 3 times 8 plus h plus 12, like that, minus f of 8 is going to be the square root of 3 times 8 plus 12. That's the numerator. Denominator just says h. We can expand this binomial here in the numerator. We can evaluate the radicand here. So we're going to get the limit as h tends to 0. So 3 times 8 is 24 plus 3h plus 12. 3 times 8 is 24 plus 12 is 36. Square root of 36. And we can combine. So 24 plus 12, and this is a perfect square, so we can take the square root of the square root of 36 to clean it up even further. So we have the limit as h tends to 0. So we're going to get the square root of 3h plus 36 minus 6 over h. Now, we want to evaluate this limit as h tends to 0. We cannot substitute in 0 because it would end up in the denominator, which is not permitted. So we need to change or simplify this expression in such a way that the h is eliminated in the denominator. So what we're going to do here is we're going to multiply this by the conjugate. So times, the conjugate here is going to be square root of 3h plus 36 plus 6, and the same thing in the denominator. Right? Now in the numerator, what we have here is a product, and this is the factored form of a difference of squares. So we're going to work backwards here and rewrite the numerator as a difference of squares. So we have a limit as h tends to 0. And so the first term squared, square root of 3h plus 36 squared minus 6 squared. This is a difference of squares. If you factor that, you get this product here. In the denominator, we have h times square root of 3h plus 36 plus 6. Let's evaluate the square terms in the numerator here. If we square a radical, the square root disappears. So we're going to be left with 3h plus 36. And then 6 squared is 36 minus 36. Denominator, we're going to keep it factored form. So it stays the same. Now we can see that 36 minus 36 just disappears. And this h here cancels against this h in the denominator. So we're left with the limit as h tends to 0. In the numerator, we have a 3. In the denominator, we have a square root of 3h plus 36 plus 6. So at this point, we can substitute in h equals to 0. So we're going to get 3 over. So it's going to be square root of 3 times 0 plus 36 and then plus 6. So this radical will reduce down to 6. 6 plus 6 is 12. And this can be reduced to 1 over 4. So this here, a quarter, that's the slope of the tangent line. Now we want to express or write the equation of the tangent line. Okay, so we're going to be using the point slope formula. So y minus y1 equals m times x minus x1. We have the slope, it's a quarter. We have the x-coordinate of 8 right there given to us. We need to find the corresponding y-coordinate. So we would say that when x equals to 8, then y equals to square root of 3 times 8 plus 12. And if we evaluate that, we're going to get square root of 36, which is 6. So we have a point now with x-coordinate 8, y-coordinate 6. So now we can plug it in here. So y minus the y-coordinate was 6. Slope is a quarter. And the x-coordinate was 8. So we're going to rewrite this in general form. So we're going to expand this and move everything over to the left-hand side. Okay, and minus 2. Now we move everything over to the left-hand side. So we're going to get negative 1 quarter x plus y. And then we have negative 6 plus 2. That's negative 4 equals to 0. Now, when we're providing the equation of a tangent line in the general form, we never want to answer in such way that the coefficient in front of the x term is either negative or a fraction. So what we're going to do here is we're going to multiply the left and the right hand side by -4. So if we do that, on the left hand side we're going to get just x minus 4y plus 16. And on the right hand side we're just left with 0.